This conference will now be recorded.
Hello everyone, let us start the session. So this will be the first session of the Ethernet protocol and Ethernet core verification using system Verilog and UVM. So as you can see from the heading of the course, we are going to learn two aspects: the protocol and the core verification. Okay. Before we start, we had given a long gap for many of you. Reason was to we want you to gain that expertise with SV and UVM. In previous batches, what used to happen is we used to complete UVM. We used to start off with the project immediately with not much gap. So there, the students didn't had enough time to gain that expertise with the language and methodology. So I hope you have utilized that gap. Whenever gap is given, it's not just for relaxation or anything. It's for you to gain that expertise with the language. And as you know, many places hiring would have been happening based on SV and UVM. If you are very good with SV UVM, maybe AXI protocol or how to develop test bench component assertions and coverage, that would be sufficient. So now we are moving to the next aspect of the course, which will give you exposure to how the things happen in the industry. Why this is important is after 1 or 2 years, when you get into a client project, let's say you join a company, you get into a client project. That time you will understand that SVUVM is not getting used at all. Lot of things you learned is not getting used. What is getting used is this project action. The knowledge you gained in this project will be more relevant. Like how do you debug? How do you develop test plan? How do you list down coverage points? Okay. How do you implement a register model? How do you write register test cases? I'm not telling that SVUVM is not important. They are important, but this will become more relevant for you actually. So I want you to spend this 5 to 6 weeks time dedicatedly on this, while you spend 1 hour a day revising SVUVM so that you don't lose that focus. Make sure that you do this along with the our mentor. I mean, mentor will be guiding you, right? So the initial few sessions, it could be 3, 4 sessions, are focused on the protocol. Later, we'll move on to the Ethernet core verification. The Ethernet itself is like a very big protocol, vast protocol. If you ask me how much I know in Ethernet protocol, very little, because Ethernet itself has many revisions: 100 Mbps, 1G, 10G, 100G, 400G, and it can work up to 400 gigabits per second. That speed it can work. So when it can work at that speeds, the protocol complexity increases actually. They go to that level by adding more layers into it. Okay. There will be some PCS layer, different layers, which even I am not really aware of too much into those advanced. But as far this course is concerned, I am comfortable. I can handle easily. Okay. What is required for this? So among all those layers, one of the layer is the MAC layer. I told you, right? There are many layers. One of the layers is MAC layer. So here we are talking about an Ethernet core which has got a MAC inside it. Ethernet core in which MAC will be there, and other than that, the physical layer will be there. So I will be explaining as you go forward. We will understand all those aspects. So what we have done is overall project wise, you have done one project which is based on chip protocol, AXI. Some of you or many of you have done AXI protocol. There you have learned an on-chip protocol, how to create a AXI transaction, how to define AXI interface, how to do AXI driver, AXI sequencer, monitor everything. Here we are going to learn the other aspect. Ethernet is a peripheral protocol where the communication happens in a serial manner. So you will get exposed to the other side of the protocol also. Okay. That is the reason we have selected this course. There are other designs we could select. We have another set of designs in the institute, but we didn't want to do that. We wanted to do this so that Ethernet looks good in the resume. Okay, it will give you that start point where you can start learning the advanced things also. Once you learn Ethernet this version, it will give you that enough expertise where you can start reading the little complex things. Let's say you learn here Ethernet 100 Mbps. Next you can start learning 1 Gbps. What will be the additions? that have been done to support one Ethernet 1 Gbps speed. Okay, definitely they are not same, right? If they are same, then we wouldn't have different versions. There is something that has been added in Ethernet 1 Gbps, Ethernet 10 Gbps, 100 Gbps to make it compatible. Okay? It will set that foundation for you. So, having said that, let us get into the course and start with the protocol. So, as I said, there are two agendas. One is the protocol training. The first thing will be focused on the learning of communication protocols, the computer networking. What exactly we mean by computer networking? Then what is meant by Ethernet standard? And then different IEEE networking standards. See, there are different networking standards are there. What are those networking standards? Then we'll talk about OSI model. Okay. Then we'll talk about different layers in the OSI model. Then our Ethernet MAC, what we are going to verify will be as per 802 standard, 802.3. In 802 itself, dot 1, dot 2, dot 3, like that. Dot 24 is also there. 802.1, 802.2, like that. 802.24. Some numbers are there. What we are going to focus is on 802.3. Okay, we'll discuss all that. So that will correspond to the MAC layer. So we'll focus on MAC, that is the media access control layer. Then we'll get into the MAC architecture. So this is the protocol training part of our agenda. The next part of the course will be focused on the MAC verification, the Ethernet core verification. So there we'll work on the entire flow. This is actually important for you, because till now you haven't done any project where you have got this entire flow. You may have got an exposure where how to come up with the test bench architecture till this point, where you know how to develop test bench architecture, how to develop test bench components, how to integrate test bench, write test cases, and then do the scoreboard implementation. For industry, these are also very important. These are also very important. Actually. Many times you may just be doing this work only. Many times you get into a project, you won't do this, you won't do this. You may only do this work for 1-2 years, all at a stretch, where you are only doing coverage analysis, where you are only analyzing the test case failures and debugging those failures. So this course will give you that entire flow exposure. So the flow will start from taking the design specification, reading that specification, understand the architecture, understand interfaces, different registers, the subblocks, then come up with the verification plan, come up with the test plan, list down the functional coverage points, develop test bench architecture, implement the different test bench components, then register model development and integration, integrate the entire test bench, develop some basic sanity test cases, develop functional test cases using register model, then implement the scoreboard, then implement regression flow, then do functional and code coverage, report generation and report analysis also, then develop more test cases for coverage closure. So this entire flow will be doing. This is what is done in the industry. You get into any project, you will be doing this kind of flow. You will be fitting into one of these parts. Okay. Next. First, let's understand the design complexity. Let's say till now you have done something like memory verification. It's a very simple design. Ethernet MAC is little complex. How do I measure that complexity? How do I say that Ethernet MAC is complex and memory is simple? So one of the measure is based on the number of features in the design. A complexity of a design is measured based on the number of features in the design. Let's say remote control is there, projector remote control. Then I have got mobile phone, which is more complex. Mobile phone. How do I say that it's more complex? It has got more features. Camera, audio, video subsystem, graphics, lot of things are there. Whereas remote only has one way, one control concept to remotely control the projector. So, talking about that, design complexity is measured based on the number of features in the design, which will finally translate into number of registers. To implement a feature, you need a register. To implement some feature, you need registers in the design. Registers are nothing but the set of flip-flops. One register generally will be 32 bits in size. One register will be 32 bits in size, so it will be consisting of 32 flip-flops. More the number of features, more the number of registers we will require. So essentially, if given a design, how will you check whether it's a complex or not? If you have a big set of registers, it's a complex design. Now, what is meant by that big number? Anything more than 50 registers, 100 registers, it's a complex design. I mean, if it is more than 100 registers, 100% complex design. Because so many things you have to control through the registers. Okay. To take a simple analogy, a traffic light controller versus mobile phone. You know which is complex. The mobile phone is quite complex. See, mobile phone has lot of features, whereas traffic light controller has only one feature. What is that? State machine. It has only the state machine, FSM. Okay. A router has only one feature, for example, where it has no registers. Hence, there is no complexity at all. Okay. Whereas when we come to Ethernet MAC, okay, it has got 20 plus features, like half duplex, the half duplex transmission, full duplex transmission, the control frames, support for pass frames, support for interpacket gap, the buffer descriptors, different types of interrupts, then media independent interface, then the collision detection. So there are different such features which makes this complex. Okay. A design complexity is measured based on the number of features. Number of features translates into number of registers. So more the number of registers in the design, more will be the complexity. Now let us start with the first topic of the agenda, that is the communication protocols. See, there are different peripheral communication protocols are there. USB is there. Through USB also you can do communication, right? You can send the data. PCI Express also you can use. You can use SATA. Okay. Then you can use DDR. You can use HDMI. You can use VGA, SPI, I2C, UART. These are all the different types of peripheral communication protocol. You may say, why are you not including AXI, AHP? It doesn't fall under the peripheral category. They are on-chip protocols. Okay. So the question comes, with so many protocols, what is the need for a new protocol like Ethernet? Question comes, when I already have so many protocols, why do I need a new protocol like Ethernet? Why did they introduce Ethernet altogether? Answer is simple. I mean, existing protocols are not able to meet the networking specific requirements. See, networks has a specific kind of requirement where they should be able to work in full duplex mode, half duplex mode. They should be able to do the collision detection. Okay. So there are some features which other protocols like PCI Express, SATA, HDMI, they are not able to fulfill that. So Ethernet is specifically for the networking communication purpose. So as we go forward, we will understand what is that Ethernet specifically introduces. I mean, how end of this course, maybe end of another 3-4 sessions, if you ask yourself why USB is not able to do the same work. Let's say in our whole institute, if you see, is connected through Ethernet ports, where we have a server. You can sit anywhere and connect through the Ethernet cable to this one. Now you should ask same question, why we are not able to use USB ports? Why couldn't we connect a USB cable there instead of Ethernet cable and everyone connects through the USB? Okay. The first answer will be Ethernet provides a concept where any component in the network can initiate a transaction. For example, I can initiate communication to other component in the system. I mean, if I set up such a network where this is the router or a switch where I have connected multiple things. This is your laptop. This is her laptop. This is your laptop. This is my laptop. Once they are connected through local area network, as of now, actually in the institute, we haven't set up local area network. It's all connected to the server. But if you set up a local area network, any component will be able to access any component directly. This is where a lot of these protocols will fail, because in, let's say if I take USB, everything is host controlled. The host will only be able to write and read. These components won't be able to initiate it. So given these kind of requirements, Ethernet has been introduced to meet this specific kind of requirements. DDR, PCI Express, SPI, whatever protocols you see here, it is not suitable for this requirement. It's not suitable for this kind of requirement. What are the networking protocol requirements? Okay, first of all, LAN. See, local area network requires different types of packets. Network means what? Network requires different types of packets. All these packets needs to be encrypted. So you can do some research on this topic. I mean, what is meant by encryption and all that. I mean, why encryption should be done? Let's say if I'm sending some data to some place. I mean, let's say I am sending an email to some of one of my friend in different place. How do you think that is getting carried? Is it getting carried through the USB, PCI Express, Ethernet, or how is it getting? It is finally getting converted into some IPv4, IPv6 packets. That is essentially the Ethernet standard, one of the Ethernet standard, and then it's getting carried. If you don't encrypt it, anyone can actually tap that. They can encrypt, they can decode what is the message you're sending. So there is a need to encrypt those packets. So these are all things which Ethernet can provide. Okay. Where Ethernet protocol is used, it is used in networking communication. Okay, in networking communication, what are the different types of networks? When we say networking communication, what are the different types of networks? One is the LAN, which is local area network. Then networks which are connecting the different LANs. Multiple LANs are interconnected with each other. So you have got a LAN. What is the LAN? You have got a router to which there are multiple nodes connected. You set up one more such thing. These things connected makes a connection of interconnection of the LANs. So what does Ethernet provide is, what does Ethernet do is a low cost implementation of the networking communication. See, whatever this communication has to be done, it makes sure that this whole implementation is done at a low cost, and it provides the ability to secure this data. Ability to secure this data. In USB, we don't secure the data because do I use USB cable to send my data from here to some other place? It's only for local, I mean, within a short distance only, right? So because of that, in USB, they didn't introduce the concept of encryption at all. We don't secure the data because I know that from here, I'll send only to other place within few meters. Okay. And Ethernet is also used where we need very high speed communication, like 400 gigabits per second. Now the question comes, why can't we use USB for network communication? I said, right, why can't I use USB from my house, from the office room till here? First problem is signal attenuation. What is meant by signal attenuation is USB cable can only be few meters, 1 or 2 meters. Beyond that, if you do, the signal quality will degrade and you won't get the data properly. Let's say if I connect a 10 meters USB cable, I may not get the signal properly. I may not get the data properly because of the signal attenuation. See, whatever is being sent, it is sent as a current, right? It may not have enough drive strength to do that. See, what is attenuation essentially is, it's a metal wire. USB cable is a metal wire, right? On that you are sending the current. When you are sending this current, so what happens? There is a resistance. This offers a resistance. The metal wire offers a resistance, and by the time it comes, the voltage will drop. Now the signal may degrade and I may not be able to detect the signal properly. And USB can't encrypt the data. Okay, these are some of the problems with the USB. Like that, if you start looking at DDR, PCI Express and other options, you may see similar problems. Need not be the same one, but other things which will not make them suitable for networking requirements. So I want you to do that research. Why Ethernet is only used for networking? Why not any other protocol? This can be one of the interview questions. Let's say you come for an interview. I'll ask same question. Why Ethernet? Why not USB? So you should have a convincing answer. I mean, Ethernet is a kind of protocol. First is what? Which allows for any master, any node to initiate the communication. See, let's say I want to send a mail. It should not be like I should request my network service provider generate me a request for email, then I will send. It's not like that. Okay, I can just initiate the email because I am one of the node. My laptop is one of the nodes in the network. I can initiate the email. So that is what Ethernet provides. USB doesn't provide that. Let's say I'm one of the device in USB, like pen drive is there. Pen drive by itself cannot initiate a transaction. It is the laptop which has to say, I want to write to the pen drive, I want to read from the pen drive. So these are few of the things which sets USB apart, sorry, Ethernet apart. Now let's understand what do we mean by computer networking. Okay. What is meant by computer networking? A basically group of computer systems or any hardware devices. It can be the computer systems or hardware devices, right? Linked together through a communication channel. See, this is all the communication channel we are talking about. They're connected through a communication channel. These are the communication channel we are talking about. And they facilitate communication and resource sharing. What is the need for a networking protocol standard? I mean, first of all, let's understand why do we need a networking protocol standard? Means why do we need 802.3? Okay, some standard like that. See, who maintains that 802.3, 802 standard? It is maintained by IEEE. That means what? IEEE has a group of people from different companies like Cisco, Juniper Network, different companies. Whoever works on Ethernet. Okay, it could be even which company? Qualcomm, Intel, every company. Whoever has a Ethernet port, they will be part of that group. So they decide some standards. Why they together decide is, for them it's like an agreed convention where, let's say Ethernet, Qualcomm develops a laptop with Ethernet port. Some other component, some other company develops the routers. Let's say, does Cisco manufacture laptops? What do Cisco manufacture? Routers and routers, right? Some other company manufacture Ethernet cable. They don't manufacture router. They don't manufacture laptop. They manufacture cable. So different companies manufacture different Ethernet related components, cables, routers, the host, the laptops. Okay, they need to have an agreed convention how it is going to work. So if I develop cable based on my understanding, let's say generally if you cut Ethernet cable, you will see some 7-8 wires, eight or more than that wires. So I am developing a cable with that assumption. If other company who is developing the laptop with Ethernet port develops the port with a different assumption, then they won't be compatible, right? So there need to be some protocol standard which all these companies follow. That is called as IEEE standard, IEEE 802 standard. Now inside that IEEE 802, what are you doing? What is your goal? Wireless network, wired network, okay, like that WWAN network. Some different categories are there. Okay, man metropolitan area networks, different subdivisions are there. So based on what is my target, am I developing a wired connection based one, wireless connection one? So I need to follow those guidelines. Even in my laptop there are two standards, one is wired, one is wireless also, right? Through wireless also I receive the signals. So those standards are very well defined. That is why we need protocol, networking protocol standard. So as I said earlier, here you see there are multiple companies working in the networking domain like Cisco, Juniper Network, TP-Link, Tejas Network, Huawei, and even any company which has got a Ethernet port is also working, right? Qualcomm is working, Intel is working, because if Qualcomm is not working, this port won't be there. Intel is not working, this port will not be there at all. Okay, all the laptop manufacturers, they also need networking logic inside their hardware. So any component that has Ethernet port is a networking component. So if there is no standard, what happens? Every company develops the products on their own understanding. Then compatibility issues will arise. Hence, there is a need for a standard. So IEEE standard for Ethernet is what? 802. Anything related to Ethernet is 802. So Ethernet is a complex protocol. It is complex because it needs to support very high speed transfers up to 400 gigabits per second. It works with a very minimal errors, ability to recover from the errors. I mean, it should, whatever error happens, let's say I send a packet, there is some error. It should recover from those errors. It should correct the packet and send it. Okay. Ability to encrypt the packet. So there are a lot of requirements for Ethernet that makes it complex. Okay. As I said, what is the need for IEEE standards? Different components are developed by different companies. So there are different, so hence they need to have that standard which they follow. Let's say if I know I'm going to develop a Ethernet wired connection, I'm developing a Ethernet port, I need to follow that specific standard 802.3 standard. I need to download from IEEE. I need to follow each and every guideline there, and accordingly only I should develop my design. There are different types of networking requirements like wired connection, wireless connections, WiMAX, broadband, metropolitan area networks. So there are different types of connections. So company has to decide what are they targeting. So companies developing the networking hardware needs to follow a set of guidelines so that those devices are compatible with other devices in the network. Okay. I hope last slide and this slide was explaining about why we need standards. So now let us get a little bit into what are those standards. So okay, ISO networking standards. I as I said, 802 stands for Ethernet related LAN standards. These are the set of local, one mistake, 802 is not for Ethernet, 802.3 is for Ethernet. 802 is related to the LAN technical standards, local area network related technical standards. Okay, so this statement is wrong actually. I mean, but if at all you want to write for Ethernet, you should write 802.3. Okay. In 802, IEEE 802, you have got various standards like 802.1, .2, .3 up to where? .24. 802.3, see, not all of them are used currently. We don't use all of them. I mean, do we use 24 standards? We don't, because we don't really come across so many requirements. Take your day-to-day life in a laptop, what all things you want to do: wired connection, wireless connection. So that makes two. Okay, so that makes one is wired LAN, one is wireless LAN. Sometimes you have broadband connection. There is one more standard. You can think of another 3-4 standards maximum. So that is where a lot of these 24 standards are redundant. They are deprecated. Companies don't use it. So we'll go through that also. The current project which we are going to work, we are using MAC for wired LAN connection. We are working on a Ethernet core MAC, Ethernet core which has got a MAC, which will be used for wired LAN connection. That means what is the standard we are going to verify? 802.3 standard. So currently what are the active standards? 802.1, 802.3, 802.11, 802.15, 802.18. So there are 5 standards which are currently active. Okay. If you want more details on this, you can go here. Just you say IEEE 802 standards. Simple. You will get 802.1 is for what? Bridging purpose. 802.2 is for logical link control. Disbanded means what? It's not used. Whatever group was there, they have removed that group. They don't need that group. That means no one works on this standard. 802.3 is what? Ethernet. So what does it provide? Provides asynchronous networking using carrier sense. It does something called as carrier sense. It senses the components in the network. Multiple access, multiple components can initiate the transfer. With collision detection, if multiple of them try at same time, there will be collision happening, right, in the common network. That detection also is there. Over coaxial twisted pair copper optical fiber media. Current speeds range from 10 Mbps to 10 gigabits per second. Like you see, there are many groups, they have been disbanded. 802.4 was for token bus. 802.5 is for token ring. They have been disbanded. That means they are not relevant at all right now. Like that, you can go through the standards. For example, we have Wi-Fi, which is 802.11. So this is the standard for that. So some of you can just go through them and try to understand what is the significance of this. But this should be the later part. First you should focus on what is the current project we are doing. You should try to understand 802.3 standard. When time permits, you can go to the other standards. So while developing a router, let's say I'm developing a router, right, 2 types of routers will come. Right, in Ethernet, it's in the LAN connection itself, you will come across 2 types of routers. One is wired router, one is wireless router. Are you clear with that? When you buy a net, Ethernet, when you buy a internet connection, they will give you wired LAN, wired router. Then they will ask you to buy wireless router, or they will also give both of them. So one of them will be working on 802.3 standard. Wireless router will be working on 802.11 standard. Now, if you ask me what is the difference, there will be difference in terms of the packet format, different things, how the communication is established. There could be difference in all of them. Router, just as a hardware, will not function actually. We need to develop both hardware and corresponding drivers also. See, there will be drivers specific to my router. Drivers means the firmware. Only when drivers are installed onto the router, then it will start. To understand this 802, this networking protocol, let's take a simple analogy. Okay. Here we are trying to understand the different layers in the OSI reference model. So the point I'm trying to tell here is, till now we have learned simple protocols like SPI kind of protocols. They work at very low speeds, okay, and they don't have complex features. Because they work at low speeds and they don't have complex features, their implementation is also simple actually. Okay. The whole implementation is done as one single core. When you come to Ethernet, PCI Express, USB, what is special about these protocols? These are very high speed protocols. For example, USB can work at 80 gigabits per second, generation 4. USB 4 Gen 4 can work at 80 gigabits per second. PCI Express can work at very high speeds, 64 gigatransfers per second. So there are different speeds. SPI works in very small speed, megabits per second. So in those cases, you don't need complexity. SPI doesn't require any complexity. Whereas when you talk about the peripheral protocols, high-speed peripheral protocols like Ethernet, PCI Express, USB, SATA, they need something called as layered architecture. Okay, they need layered architecture where the functionality is divided into different layers. If it is a simple functionality, no need to divide it. It's like institute. If it was a very simple thing, one course, very few students, only one person is sufficient to handle everything. When they have multiple set of people, multiple batches, multiple courses, you need a division of the whole work. That is what we have done. Same way, when you move from SPI kind of protocol, which is low speed, very few features, read and write, simple. In SPI, you do what? Read and write. You don't need complexity. There, we don't go for any layering. Whereas in Ethernet kind of protocol, what we do is we take the entire functionality. The entire functionality is divided into different layers. These layers are called as OSI reference model layers. OSI layers. Okay, if you remember, can you tell me how many layers are there in OSI? 7 layers are there. What are those 7 layers? Very basic level, what do you have? Physical layer. Then you have a data link layer. Then you have a network layer. Then you have a transport layer. Then you have a session layer. Then presentation layer. Then application layer. So these are the different layers which we are talking about. Our Ethernet MAC is only this. Ethernet MAC is only implemented in these things. Now let us understand how to analyze these layers. These layers, you can think of some of these layers are implemented into the hardware. Some of these layers are implemented in the software. Software means the drivers, applications which work on this hardware. So the application development part will come here. The hardware related thing gets implemented into network layer, data link layer, and the physical. Means any electronic system you take, even a mobile phone you take, the mobile phone functions not just because of the hardware. It has got hardware plus the drivers which work on that. That drivers constitutes this part, upper layers. Means it could be application, presentation, or session only, but they constitute the upper layers. Hardware is implemented into the lower layers. So this kind of division, what is done in the OSI reference model. Now, one thing about OSI reference model is it is called as reference model because it is not a rule that you should definitely implement physical layer, you should call it as data link, you should call as network. No. If you go to PCI Express, they still use some layering. Here they call it as physical layer, this they call it as data link layer. Here network, instead of network, they call it as protocol layer. Sorry, transaction layer. So transaction layer, data link layer, and physical layer. If you go to USB, instead of calling transaction layer, we call as protocol layer. So there could be different naming, but it's all about division of the functionality into different layers. So why do they such division? Now you may ask, why did they do such division? It could have been named as one single layer, right? It could have been named as one single layer. I mean, instead of going for 7 different layers, we could have named it as this entire thing as one layer, this entire thing as one layer. The reason they have come up with different layers is they have assigned different activities to each of them. For example, what is the bottommost layer? physical layer. The physical layer is responsible for setting up the connection. You've got a connection, right? One Ethernet port is connected to other Ethernet port. So through a LAN cable. So it physical layer makes sure that this LAN connection, everything is set up properly. It's in a position where you are able to transmit the data. The data link layer ensures that whatever packets I send from here to here to the other component are going without any errors. You see, physical layer is not responsible for that. Physical layer doesn't care. Let's say even if some packet comes with error, it doesn't even know that there is some error and it doesn't even bother about that. Who is the layer which bothers about that? Data link layer. So like that, different layers have been given different activities. Different layers have been given different activities, so they accordingly get implemented. So to understand this concept of OSI reference model, let's take one example. Please read that once. Okay, to understand this, let's take an example of a food delivery service. Okay. See, as a user, you want to place an order, places an order and gets the item. So it started with you placing an order, it ends with you getting the item. So at the top level, if you see, there are two entities involved. We'll call them as two different nodes. Okay. One is the customer. It is a node which is placing the request. Restaurant is the other node servicing the request. You are placing a request, you want this specific item. The restaurant is the node which is servicing your request. So this entire nodes are connected by the delivery service called as Swiggy, Zomato. These are the things which are connecting this. They provide you the required infrastructure to place the order. Then they carry the order to the delivery agent. They inform to the delivery. They carry that communication, that request to the delivery agent. Then delivery agent go to the place and carries the packs. He won't just bring with the open thing. He makes sure that everything packing is done. Then it is carried. Once you get it, you don't consume with the pack. You remove the pack. Then you consume it. So that whole process is happening, right? First, food is prepared. It is being packed. Then it is being sent through a carrier and you are receiving. Now, even in that process, there are two ways it could have been carried. One is through a bike, you could carry it through a bike. The same food item could have been carried through the drone also. There is a drone which is present at the restaurant and they will set the target location and drone can carry. So in summary, whatever data that wants to be transferred from one node to other node could be transferred in a road network, which is like a wired connection. It could have been transferred through airway, which is similar to wireless. But at the end, it's all about transferring data from one place to other place. Okay. So the delivery agent will carry in a different manner, drone will carry in a different manner. So it's all about how that is done. So these are those 802 dot standards. One will become 802.3, one will become 802.11 standard. Now in this, let us understand what is the role of a different layers. Okay, there are different layers that are coming into picture even in that food delivery service. Okay, when you want food, you open the food delivery service website, you you get an application there. At your level, at your point, there is an application. Do you go to Zomato, Swiggy office and there you place the order? No, right? That entire application is available at your place. So there, through their application, I'm just trying to give an analogy. This need not be the exact thing. I'm just trying to correlate different layers, how they connect to this food delivery service. So you open that application, it will give you a presentation of the order, different presentation. You create a session. What is the session? Session gets created on the Swiggy platform. This exists, this session will exist till order is not serviced, till order is not closed. It will continue to exist. That session continues to exist. So you went to the application, through application you created a session. So once the so this request order goes to the restaurant. See, this is all we are talking about. The customer node, customer node went to the application, he saw the presentation, then he created a session that has created some packet. That information through the Swiggy network. See, Swiggy has a network, so that's what we are calling as the local area network or wireless network. Okay, different networks. It is finally getting carried to the restaurant. Now restaurant also has similar thing. They have their own application layer, the presentation layer, the session layer. So there also, probably for them also, one session gets created. Whatever session you created, their session, they get mapped. So based on that session, order will be prepared. So you see, whatever you see in the red color, I mean, these things were all done at the software level. I mean, they are done at the as more like a driver level. So there is no physical data transfer involved there. Once the order is collected, as I said, that need to be delivered. So there will be three four things involved. One is, whatever the path he has to come, let's say he is coming physically through a on the road bike. So is that road in a proper condition? That is the responsibility of the physical layer. Even in our example, food delivery service example, the role of a physical layer is to make sure that whatever road that is connecting the restaurant, okay, and whatever is the customer place, okay, is it proper? Can the bikes go in that path? That is what physical layer will check. Understand here, application layer, presentation layer, session layer doesn't bother about that, because when I place my order, I don't know what is the road condition. I don't bother, because at application, presentation and session layer, it's my responsibility to just place the order, okay, and create a session. The data link layer, tell me, what do you think data link layer will check? Tell me, what do you think data link layer? If item is delivered, okay, is it delivered properly? Let's say you have ordered for 7 items. Did all 7 items came? Did they come in a proper packed manner? Okay, is there any spilling? I'm just telling, that is what is the responsibility of the data link layer. And then once I know that it has come properly, I'll give an acknowledgement that I have received properly. Though in our case we don't tell that, it's like more like complaining. That's, let's not get into so much exact correlation. I'm trying to give you correlation of what is the different layers and how it can be correlated to our networking protocols also. Then you consume. My network layer will consume the packet. It could mean writing the packet into, I mean, in our case, we are having the food. In network layer, whatever packet comes, it will consume that packet. Right? So this is how different things happen. Once this is done, probably the session layer closes the session. So order is collected, customer collects the item, session is closed, and application and restaurant also closes the order. So you can think of different layers, like upper layers, like application layer, the presentation layer, and session layers are more like software layers. You remember, right? Even in the food delivery service, there were two parts. One that is done on the computer at my place, also at restaurant also. See, how will restaurant get that order? They have their system where that order will show up. That order continues to exist for them till I receive it, right? Even if it goes, it still exists with them. Only once I tell that I have received the order, everything is proper, that information gets communicated to them where their session gets closed. The lower layers, which form part of the hardware layers, the physical layer is responsible to make sure that that connection is proper. Okay, it doesn't check whether the item has got delivered properly or not. It doesn't even know whether how many items are there. It only knows whether that connection from that point to this point is proper. Is it in a position where it can be sent? Data link layer ensures that it is received properly. It doesn't consume that. It only checks. Okay. Now it could be like the person who takes delivery. Let's say I have a security in my house. His role is to collect and check whether 7 items have come or not. But he doesn't consume it. He will hand over it to me. So I am the person who is going to actually consume it. So I am like the network layer. See, will there be anyone above me who will consume it? No. So that is where hardware will stop. Then I will log into the system. I will say entire process has been completed. So rest of the things are done by software layers. So this concept is important. Why this concept is important is this is how all the hardware works. Any hardware you take, any complex hardware, it works like that only. You take USB. The USB has two parts to it. USB hardware, the USB software. We don't, instead of calling it as software, we call it as the USB drivers. The drivers of USB will constitute this kind of part. The USB hardware constitute this part. Not exactly same name. See, in USB you don't have a network layer actually. You've got something called as, let's say, protocol layer. It could be a different name altogether. It could be transaction layer, link layer. So depending upon what is that we are talking, the layer names can change. In summary, it is just a reference model which tells how the functionality should be divided into software, hardware, and the software portion. You see, in the same food delivery service, with thousands of people placing thousands of orders from thousands of restaurants. What is the complexity there? If one person is placing the order, there is no problem at all. My network can easily handle it. Okay. Now with thousands of people, that's the reality, right? In Swiggy kind of platforms, thousands of people are placing orders from thousands of different restaurants, and they are placing thousands of orders. So all orders are tracked using a different sessions. That is the session ID. Each order has a session ID, order ID or session ID. So that also gets created, that gets tracked. Okay. So what medium to use? Whether to use a bike, whether to use a car, whether to use a drone. So bike will be like a wide LAN. Drone will be like a wireless LAN. Okay. Now what can go wrong here in this whole process? Our application doesn't work. The order doesn't get placed. The delivery boy doesn't deliver it to the required place. Some item can get misplaced. The item may get delivered to a wrong location. So there are many problems, right? So there has to be some system which is used to rectify those problems. So Ethernet will have all such things to fix those issues. So with this understanding, let's talk about OSI reference model. Now before we start with this OSI reference model, let's again understand why did we talk about that food delivery service. There we have understood that food delivery service is not just about a delivery boy going there and getting item and giving you. It also has other things where you log into a system application, you create an order, that order gets delivered to the restaurant. So there we saw that two parts of the functionality is there. One which is done through the people, the delivery boy and the security and me. One which are done in the other layers, upper layers, application layer, session layer. Now let's understand what is this OSI reference model. Understand, it's a reference model. Reference means what? It's just a guideline. Whether you use it not use it is up to you. They will just give guidelines that in this layer you should do this, in this layer you should do this. Now whether you do exactly the same thing or you change it for your requirement, it's up to you. OSI reference model, there are n number of users who use computer network and are located all over the all over the world. So to ensure national and worldwide data communication, systems can be developed and are compatible to each other. I mean, to develop the systems which are compatible with each other, ISO has developed a OSI model. It has developed a OSI model. ISO here stands for International Organization of Standardization. This is called a model for open system interconnection. The OSI stands for what? Open system interconnection is normally called as OSI model. So all networking standards are developed using a common reference model, that is this OSI reference model. Divide any networking device implementation into two aspects. Any networking device you want to implement, let's say you go to Cisco. Cisco will have router. Router is the bottom layers. Router, if you take physically the router without anything inside it, just the physical hardware without any application loaded, it will just be these layers. Just the router alone will constitute network, data link, and physical layer. If you buy the router, it won't work as it is. If you just use the only router hardware, it won't work. When they give you the router, they would install some drivers on it and they will give you. Only then it works actually. That is these layers. So when I use a wireless router in my house, it has got both the things already loaded into it. Router itself, what you see is the bottom layers. What are the bottom layers? Physical layer, data link layer, and network layer. In that router, some drivers are already installed. You can just go and search the wireless router drivers. Maybe even I have never tried it, but you will see, right? I think when you buy a laptop, sometimes my wireless wireless doesn't work. They will ask, go to this place and download the drivers. Then only it works. That is what I'm talking about. Actually, that constitutes the upper parts. Okay. As I said, analogy. It's like a phone without OS and drivers. It won't work, right? So phone is the hardware. Phone has two things, hardware and the software. Software has drivers, OS, and application. Even phone has a modem. It will have all these layers. Any Ethernet related thing will have all these layers. Okay. Now, if I'm developing a router, okay, I need to ask myself. See, there are two kinds of companies. One is OEM, original equipment manufacturer. So original equipment manufacturer in this case could be, let's say Qualcomm is the OEM who actually manufactures the hardware. The Qualcomm doesn't give the drivers. They will only manufacture the hardware part. So what is their role? They're working on the lower layers actually. Then they sell the hardware. Let's say some company purchases it. Okay. They will develop the upper layers. Upper layers means they are not going to develop any hardware because hardware is already there. They're going to develop the application and software which is going to work on top of that. That is the upper layers. Okay. So if I'm developing a router, I need to know whether am I OEM or I'm going to buy the router from OEM. OEM means a company which actually manufactures the hardware is the OEM. Okay. Let's say you're buying mobile phone. So mobile phone has this hardware chip has a OEM. That OEM is Qualcomm. Then MI, which is the brand I am using, this hardware was purchased by MI, Xiaomi, whatever, right? Then they are developing drivers on top of it or OS on top of it. So that is how that model works. Okay. The other question is, am I developing application developer driver? Okay. You got the feel of what is OS reference model, right? Okay. As a VLSI engineer, where do you think our work will be? Hardware only. So you won't do anything related to software. So our work will only be at this level. Wherever you go, if you are into VLSI, your work will only be related to network layer, data link layer, or physical layer. Because you are not expected to develop the application and session and all that, because there is a different team, driver team, firmware team, which does that work. Whatever Ethernet MAC, all the standards we talk, right? They all fit into only this layer section. Our whatever we are going to study, it is only about these two layers in our project also. So let's quickly read through the different layer functionalities. Not a very important thing, we can quickly go through. I mean, I'll only try to focus on some of the important things. I don't expect you to remember everything. So what is physical layer does? Representation of the bits. Data in this layer consists of stream of bits. It decides the data rate. I mean, it decides the rate of transmission, whether to transmit at 10 gigabits per second, 100 gigabits per second. It is the layer, physical layer is the one which decides that. It also does the synchronization. Synchronization means what? Whatever my laptop is giving, I should accept. Other component should accept. That is the synchronization. It deals with synchronization at the transmitter and receiver. Sender and receiver are synchronized at the bit level. Interface. The physical layer determines the transmission interface between devices and the transmission medium, whether it is a wired transmission, wireless transmission. Then line configuration. This layer connects devices with medium, point-to-point configuration or multi-point configuration. Then it also decides the topologies. Whether devices are connected in a mesh topology, star topology, ring topology, bus topology. Ring topology means what? They are all connected in this manner. One device, one device, one device, one device, one device. Star topology means what? This kind of connection. Okay. So there are different types. Bus means so different types of topologies are there. All the decision making happens at the physical layer. Transmission mode. Physical layer defines the direction of transmission between two devices. Whether it will be simplex connection, half duplex connection, full duplex connection. And also what kind of transmission? It deals with baseband and broadband transmission. Okay. Let's read through these some other layers. Okay. Let's not get too much into what is baseband, broadband. It will deviate our topic too much. Okay. The data link layer is responsible for framing, physical addressing, flow control, error control, and access control. So this is more important for us actually. This is more important for us because the Ethernet MAC we are going to work on, it is actually this layer. It is this layer. Okay. So what does it do? What is the first functionality of the data link layer? Framing. What is framing does? Frames are stream of bits. Frames means one unit of data. These are stream of bits received from the networking layer into manageable data units. The division of stream of bits is done by the data link layer. See, my network layer gives the data. My data link layer does the framing. It creates them into different frames, and those frames are transmitted. You remember when we talked about Ethernet frame, it is size is between 42 to 1500. The frame size can be, that is where the framing is happening. But network layer doesn't have only 1500 bytes to send. It has got lot of data to send. It's the data link layer which divides the entire data into different frames, different data chunks, and creates a frames out of it. So the network layer gives a lot of information to transfer. It is the data link layer which converts them into different frames, and those frames are transmitted through the physical layer link. Next, physical addressing. What is meant by physical addressing? The data link layer adds a header to the frame in order to define physical address of the sender and receiver of the frame. Okay. If the frames are to be distributed in to different systems on the network. Basically, it also takes care of physical addressing, where it will tell who is the source of the frame, who is the destination of the frame, so that that packet gets routed to the right node. That who takes care of that responsibility? Data link. You see, physical layer doesn't have that responsibility. If you go back one slide and see the physical layer responsibilities, you will see completely different. Synchronization, okay, data rate, the medium of transfer. Whereas when you come to data link layer, it has got a different set. The framing, physical addressing, then flow control. What is flow control? A flow control mechanism for frames to be sent. What is meant by flow control? And let me explain. When I am sending data, okay, it's like this port is sending data to this node. Okay, I'm accepting them. Okay, if I send too many data which I cannot handle, what will happen? Overflow will happen. The data will get lost. Data will get lost. So I need to control the flow. So I need to control the flow of packets. That is what is called as flow control. What is it? What is done for flow control is I will send some data about how much space I have. I'll send some information about how much buffer space I have to accept the packets that are coming into me. Let's say this is A, this is B. Node A, node B. Node A is sending the packets to node B. So node B needs to tell to node A how much buffer space it has got. Generally in terminologies it is called as credits. This is called as credits. It's measured in something called as credits. Okay. So I will tell these many credits are available. That's an indication to this one that how many packets it can send. Let's say if I say I don't have any credits, 0 credits, that means what? Don't send any packets because I am already full. Don't send any packets. If I am full, I will give credits. So it can send. That concept is called as flow control. A flow control mechanism for frames to be sent. The next one is error control. What is meant by error control? Let's say I sent a packet. For example, going back to that food delivery example, you got a curry which is not good and the whole thing is spilled over. What will you do? Will you still accept the delivery? No, right? What will you tell? You will raise a request. I mean, you will not immediately complain at the Zomato level. I mean, sorry, Swiggy application level, you won't complain. You will try to resolve with the delivery boy only. Understand, this is important. What I'm trying to tell is, you don't, when you get the delivery, a frame is like the food item you're getting. If it is not good, not proper, you will not immediately go and complain to Swiggy. You will tell to the delivery boy that, see, it got spilled over, it is not good. What he will do? He will again go back to the node which is giving and he will again carry next to it. Will he carry some other item or same item? Same item in a better format. Again you will check, for example. Again you will check. Let's again also it is not good. What will you do? Again you will tell him it is not proper. Every protocol has some rules. How many times this reattempting will happen? Let's say 3 times. For example, in PCI Express. In PCI Express, it is called as 3 times. This retry is done 3 times. All 3 times it didn't work. So then where will you go? You will go to Swiggy application and there you will raise a complaint. So you try to resolve the issues at the hardware level only. As much as possible, you try to resolve issues at the hardware level. What is hardware here? You are the network layer. Your security is the data link layer who is checking. The delivery boy is like the physical layer. So you are trying to resolve among yourself. It's like the delivery boy came and gave it to the security. Security checks it whether it is proper or not. Okay. Then if it is not proper, he will send it back to the source node, again get it 3 times. It will happen. If it doesn't, still doesn't come, then it will be communicated at the next session layer level or so, that it is not happening. Okay, then they will try to rectify. What they will try to change, they will try to change the delivery boy, or they will try to change the mode of transfer, some or other thing they will change. So there will be corrective action that will be taken care. So that is also the responsibility of the data link layer. So what is one of the responsibility? Error control. So what is it? Error control is achieved by adding CRC at the end of the frame. Duplication of the frames are also prevented by using this mechanism. Data link layer adds mechanism to prevent duplication of the frames. In summary, it makes sure that packets are delivered properly without any error. What is the last one? Access control. What is access control? Protocols of this layer determine which of the devices have control over the link at any given time, when 2 or more devices are connected to the same link. Understood? See, when multiple nodes are trying to make a transfer through the same link, access control will decide who will get the access, who will get the control. This is important for us. Next layers, network layer, session layer, application layer, they are not important, not much important. Why? Because we are not going to work at that level. Our verification will not involve any of them. Majorly, we are going to verify. Hence, these things are important. Do you remember all this? Tell me, what is the first feature of data link layer? Framing. Second? Sorry? Physical addressing. What is the third thing? Flow control. Fourth one? Error control. Fifth
Error
one?
control,
What is it?
access control,
Access
access control.
uh, control, right? So why these are important? If you go to interview, they will ask you what are the different features of data link layer. You just have to answer this. In fact, even in Ethernet MAC, this is what is done. Even if you go to complex thing, let's say 100 Gbps Ethernet MAC, that also it does the same thing actually, but at a little different level. Ethernet MAC, even in 100 Gbps, will do framing, will do physical addressing, will do flow control, will be responsible for error control, will be responsible for access control. Okay. It's not about just memorizing it. You should understand what is what. Do you understand what is physical addressing, right? Giving addressing so that it should go to the right destination. See, delivery boy which is carrying, he should have addressing, right? From where it is coming, to whom it need to be delivered. What is framing means? It should be packed in a proper manner so that it is received by me. It is delivered in a proper manner. They will do packing, right? They will do packing and all set. Okay. Flow control in our case probably doesn't apply, but in the Ethernet, why it applies? There are millions of packets going actually from my laptop to other laptop. When I do some transfer, thousands or lakhs of packets will go. When so many packets goes, every time other port need to tell, do I have space to accept or don't I have? That is called as flow control. Without space, if you send, it results in overflow. When you overflow happens, you lose the data. Then error control, access control, we have discussed. But please do read these things. Please understand these things, because this is what you have to explain when you say what is the features of Ethernet MAC. These things essentially becomes the features. I mean, we should also check that whatever Ethernet MAC we are going to verify, does it have all this? Does it have a mechanism for error control? Okay. Does it have a mechanism for flow control? So we should check all of them. Network layer, we'll just read once, but no need to really go deep into it because we are not going to focus in this. Main aim of this layer is to deliver packets from source network to destination network across multiple links. If two computers are connected on the same link, then there is no need of network layer. Okay. See, if devices are internal to the LAN, then there is no need of network layer. See, inside of the LAN, only data link layer is sufficient. Data link layer, physical layer is sufficient. But between different LANs, the network layer comes into picture. So if again to read, if two computers are connected on the same link, LAN is like a same link, then there is no need of network layer. Okay, if it routes, network layer routes the signal through different channels to the other end and acts as a network controller. Network layer also divides outgoing messages into packets to assemble incoming packets into messages for higher levels. Okay, this is about network layer. Okay. Uh, what is transport layer? Transport layer breaks the message data into small units so that they are handled more efficiently by the network layer, ensures that messages arrive in order by checking error and flow control. A service point addressing, it also takes care of segmentation and reassembling. It takes care of connection control. It takes care of flow control. It takes care of error control. See, a lot of things looks something close to what we have discussed in data link layer. So I want you to read it and try to understand how is it different. Uh, Even if you skip it, there is no problem because our focus should be on what is relevant for us. For our training, these layers are not really relevant for us. Okay. Session layer, uh, the session layer is its main aim is to establish, maintain, and synchronize the interaction between communication systems. The session layer manages and synchronizes the conversation between two different applications. It establishes the connection between two different applications. Okay, the transfer of data from one destination to another session layer, streams of data are marked and are resynchronized properly so that the ends of the message not cut prematurely and data loss is avoided. It has got something called as dialogue control and synchronization. Okay. I said, right, I told you, remember I said in the beginning of session, even I don't have the entire expertise with ethernet and all that. So this is what I mean. I never focused in this because my what I have to teach and what I have to do somewhere anywhere, it doesn't involve these things. So I didn't really go into it. Okay. So I'm not telling that don't study this at all. First you give priority to our project. Then you get time, you try to understand what does session layer does. Then what is the next one? Presentation layer does. What is presentation layer does? Some translation, encryption, and compression. What the application layer does? Some mail services, network, virtual terminal, directory services, all those things. Okay. It is safe to ignore all these layers. You can maximum study up to network layer. Okay. Up to network layer, you can study. You can try to understand everything of a network layer also. The rest of the four layers, transport, session, presentation, and application, you can ignore for now. Okay. Let's okay, let's go for a break. I think